everyone that's on, thanks for joining. This is the second episode of our Power Hour series, where this one we're going to be talking through typical electrical maintenance on an electrical network. For those that weren't on the first one or that don't know me, I'm Daniel Henderson. I'm the Global Head of Electrical Safety and Partnerships at Scanware. I'm a chartered electrical engineer based in the UK with experience. I was in the military and the Navy for 10 years as an electromechanical marine engineer, and I've got experience in renewables, fast-moving consumer goods, and heavy engineering and utilities as an electrical engineer and an authorized person and an electrical duty holder or responsible person. And hopefully now I'm working with Scanware and will be fighting the good fight in electrical safety, hence why we're all here. And I've also got Anthony Long with me today.
Yeah, hello, I'm Anthony Long. So anyone that's been on the Scanware webinars before probably heard my voice a number of times. But yeah, I'm part of the furniture at Scanware and I'm technical director here and looking to all things arc flash, both in terms of testing, but in terms of actually making the PPE that people wear and making sure it's right. And yes, any feedback anyone gets wearing any of the Strata PPE, by all means, feed it back to me, because feedback, breakfast of champions, and if we don't get feedback, we don't know if you love it or loathe it. So with that, we'll move on. Thank you. So on to this. So basically, you will receive a slide pack after the webinar via an email. So anyone that's signed up today will receive that. You'll also get a recording sent after the webinar. So after the webinar sent finished, the recording gets tidied up, and then we'll get that sent across to you. So if you need to share it with other team members, then we can we'll send that to you so you can share that with them. So also there'll be a post-webinar survey. This is important. So if you've opened Zoom up today in your browser, there'll be a question and answer page afterwards. We do really appreciate anyone's feedback on that. At the end of the day, we're always trying to move the needle forward. So any subjects you'd like to know about more, or if you'd like to change the way we do the presentations, then definitely let us know in the post-webinar questionnaire. So make use of the Q&A. So there's a Q&A box at the bottom. You'll see, so in the bottom of your tab on this Zoom screen, you'll see there's a Q&A box. You can put your questions in there and we will endeavour to answer those. And also put anything you want in the chat there. We have to run this as a webinar the way the format runs, but ultimately speaking, we'll like to be as interactive as possible. But we have got a pretty packed agenda today, so it is going to be quite tight for time, but we will, of course, try and answer any questions. So we're here for that. We're not just talking at you. We like to understand what you want to ask us so we can try and answer that as well and have some discussions. And then if you want to be automatically registered for future webinars in the series, just let us know in the chat and we'll make sure that you're always registered as a default on these webinars. And yeah, let's go for it. Go on, Dan.
Yeah, and just to add to that, last time we got a couple of suggestions around future content, which is great. So when I go through next, we're just going to cover what's going to be up until the end of the year, but the intention is to do one of these monthly. And so we've got a load of ideas, but obviously if the masses want certain things to be put in there as a priority, you know, if you're thinking it, someone else will be. So yeah, please put in any suggestions for future topics that you'd like to be included as well. Yeah, so an overview of the series, what we've got, what we've done, and what we're going up to the end of the year. It will be going into 2026, so it's not just going to cut off in December. But on the last ones, if you weren't on, you can get access to the recording. Let us know and we can get that through to you if you haven't got it. But in the first one, so obviously this is a massive subject. There's a lot of content to fit in. So the way we try to do it is as if you're stepping into the role as a electrical responsible person, as an energy marshal, as a duty holder, and then the steps you take in order to work towards having a good electrical safety program. So the first one that we went on, we were talking about electrical asset management. So we covered like roles and responsibilities, duties applied, some of the legislation that links into that, and then the first step. So building your asset lists, the asset verification process around that, why it's important. So any safety related defects or manufacturer's recalls, business impact assessments, identifying single points of failure. And then now we're going to be bringing that forward and using that content that we talked through into generating a prescriptive maintenance program, essentially. So we're going to go into that. On the next one, which is in October, it's going to be a collaborative session with we're going to be talking about how to understand transformer oil sampling, the standards that it's against, and interpreting the results, and then the outputs of that, how that links in with electrical safety, and obviously some of the mitigations around that. That's going to be done with oil analysis lab. So it sounds like a riveting subject, but it's really informative, especially for people that are involved in, FM or managing facilities where you've got oil-filled assets and things there. A lot of the time, you might not understand what those results or trends are telling you. So that'll be quite a good one. Then in November, we've got a collaborative session, again, with a power systems consultancy, where we're going to have a live protection system model, and we're going to talk through why protection systems are important. Protection studies are important for fault levels, coordination, grading, and then output into arc flash. And we're going to have a live model so we can show in the real world what that looks like when you haven't got grading, and we can change some settings and obviously talk through that process. So hopefully that'll be quite informative and interactive for the people on the session. And then finally, we're going to wrap the year up with some industry professionals on a call where we're going to go through an example electrical failure, a real life example, and we're going to go through a root cause analysis investigation with input from the attendees through the chat function through each step of the way, and hopefully try and come to a root cause. And that should be a nice way to end the year and bring Christmas in. Yeah, so Anthony.
Can you hear me?
Yep.
Yep, very good. So sorry about that. So yeah, so there's learning objectives for today. So number 1 is know how to develop a prescriptive maintenance strategy. So obviously looking at the suitable resources that's needed as part of the maintenance program that's going to be specific to the equipment and the environment. So it's making sure that you're fully aware of what needs to be done. Recognize the benefits of shifting from reactive to prescriptive. So Dan will open that up a lot. So looking at changing how your maintenance principles to improve reliability and safety. And then thirdly, to understand how to ensure equipment is safe to operate. And obviously, we talked previous webinars a lot about safe operating equipment and obviously how important that is. We've talked about arc flash PPE being the last line of defense. And so this is really, really important. Otherwise, you are literally just relying on the arc flash PPE as the main number 1 mitigating risk. So making sure that it's safe to operate is absolutely essential. So we're going to discuss that today as well. So looking forward to it.
Okay, so just we're just going to recap briefly and bring in that continuation from the last session where we have duties and responsibilities. So we talked around, didn't matter what geographical location you're in, what industry it is, whether it's a building, a site, a work site, a region, whether it's heavy industry, data centers, renewables, manufacturing. In the principles are the same. Legislation differs, but the underlying principle is ultimately someone has overall responsibility for the health, safety, and welfare of everyone in that location. And typically that'll be the person with the most responsibility. So in our example, we've got the general manager who is overall responsible for the health, safety, and welfare of everyone in that location. Obviously, this person's busy. They normally come from an operations background and they're running a business. So, and they might have limited resource capacity and lack of technical knowledge. So typically they will appoint people to manage things like high risk, high consequence systems, such as electrical in our example. So we've appointed Eddie Electrical as the electrical responsible person to be the duty holder for the electrical network on our example today. We talked about how they had key synergies with the health and safety manager. Often than not, the electrical safety responsible person isn't in the health and safety team. Often they're in a technical function. So people work in silos. So it's good to have those communication links opened up with the health and safety manager and understand those synergies around how your health and safety policy links in with your electrical safety program. And then today we've brought in operations because we're going to be impacting them. So we've brought in all the operations. Who's the ops manager, because we've got to talk through having clear lines of communication, identifying our stakeholders who we work for, with, alongside, to make sure that our sites are safe. So in the examples that we're responsible now for, the legislation will differ by area. So whether it's IEC 61936, but for European stuff, over in the UK we'll have the electricity work regulations, which will say that we must maintain systems in such a way that they don't give rise to danger, and that's typically the same terminology everywhere. And again, that's the whole principle behind NFPA 70, having those in place so that our systems are safe, our people are safe, and we have reliable networks for the safety of our persons. So obviously the responsibility is on now Eddie to make sure that this network's getting maintained and it's safe. But the interactions that we've got to have in these roles is we've got to identify the stakeholders. So your electrical network might feed a building, an office, an operations, a comms room, an IT area, areas that might have business criticality. So it's make sure we've got those clear lines of communication. And if we're doing non-invasive maintenance, or even just going into an area where it belongs to somebody else, it's about making sure that they know we're coming. They might have evolutions going on that might also be risky activity. So we don't want to put our people or our contractors that we're using in those situations. So we need to make sure we deconflict any works that are going to potentially cause harm to some people there. And likewise, if we're doing intrusive maintenance, we want to tell people that we're going to be turning off their power supplies. And from a efficiency perspective, it's always good to have those communications lined up, because we can possibly piggyback operational shutdowns and things like that to reduce downtime and utilize those outages for our benefit to get our maintenance done. At the same token, I would also say make sure you inform people if you're not going to do maintenance. So if we've got a responsibility, which we'll cover in line with a time-based program. So if we've got a planned maintenance activity that we need to deliver, in 5 years, as an example, if we can't maintain it because operations, it's a business at the end of the day. So if we can't shut down, if the business won't give us the downtime, sometimes you have a planned outage and the business might have a unplanned outage and do their operational tasking and then cancel the planned outage because they can't afford the downtime. It might be budget constraints. You might not have the budget to get the work activity done. You might not have contractor availability. It depends. Do you have busy times a year? You might have lack of resources. There's lots of different reasons why we might not be able to get that maintenance done. If we can't get it done, it's also important to tell the end clients, the stakeholders, that you're not doing it and what impact that might have. So just to make them aware, we haven't maintained this in time with our PM. We will try and get to it, or this is what we're doing about it, but the potential impacts are. And sometimes it's just good to make them aware, because from experience, if something goes off, and then and when you start investigating the impact afterwards, and you can have those conversations. If we knew this would be in the output, we would let you shut down for 4 hours to do the maintenance. So it's good to have those lines of communication. Anything to add, Anthony, on that?
Yeah, no, and just included in that as well. So some of you may be working on sites where there's different boundaries, where your work scope might boundary with someone else's work scope, and it's then making sure as well that the communication, but also understand between the two boundaries is clear. So that might be you as a contract, for example, and maybe with a customer, or maybe it might be some OEM's equipment. That there might be different boundaries. So ultimately speaking, is making sure that you're really, really clear on whose responsibility the actual work scope comes under at what point. So is it under the asset owners? Is it under the OEMs? Is it under you as a contractor? But ultimately speaking, making sure that when the work's being carried out, that whatever work's being carried out, the actual duty for that work being carried out is by the correct boundary owner. So ultimately speaking, making sure that what you're responsible for, you're clearly understanding what you're responsible for, and that is actually in your scope. It's not actually in someone else's scope that you're taking responsibility for. Because obviously, if something goes wrong, you're taking responsibility for someone else's work that's actually not in your scope. So be really, really clear when you've got boundaries. And the main thing about that as well is making sure that people are clear who they're responsible to when you've got that work that might be a cross boundary. That makes it clear.
Yeah, we'll be covering cross-boundary work in another session. We're going to be going into like the detail around managing that coordination and different ways of mitigating around that, and obviously some examples when that hasn't worked out so well, and why we need to do it, why it's quite important, especially with the communication side. But it's a really good point to add in there, Anthony. So appreciate that. So we're just going to cover maintenance types, and again, a lot of people will be on here and probably, it's saying what you know, but it's just to reiterate and go back and just reflect on it a little bit. So obviously we've got corrective, which is a run to fail approach that simply lets the equipment run until something breaks, which is, I suppose we'll all agree that's not where you want to be. We've got preventative. So preventative maintenance carried out at periodic and predetermined intervals according to prescribed criteria, intended to reduce the probability of failure. So that prescribed criteria, it might be a British standard like 6266, or it might be a IEC standard or NFPA 70B, as you can see there, which we're going to reference, or it might be the O&M manual. But it's in line with a prescriptive approach. And we've got condition-based, which is a higher level of maintenance maturity. Its goal is to enhance equipment reliability, keeping it close to its optimum condition as possible. So we're extending that planned maintenance time frame out by using testing and analytics, normally online sensors and monitoring. And then as we start to see a change, a trend difference, then we can plan a shutdown safely, make those tweaks to get it back to base standard condition, and then get it back to within that center line condition. So we're going to cover condition-based stuff down the line, especially different techniques and mitigation with some subject matter experts. So I'm not going to go too far into that. What we'll be doing in a minute is going to put a poll on just to see what type of where we fit, where everyone on the call, what if you have corrective, preventive, or condition-based as your approach. What I will say is I would probably expect that we'll have 0 in corrective, because we all sit in, we do preventative maintenance. We've got computerized maintenance management systems, we've got PM set up for everything, and typically that would be, what I would expect. And I wouldn't, I would think the professionals that we've got on, yes, that would be the case. But often, especially for like from an operational side, you'll have your PM set up, and then operations gets in the way. We might not get a shutdown, so we might have a 5-yearly maintenance required on some transformers as an example, and then we might not be able to get the shutdown because we've got production targets, so we can't get the downtime, or we might not have the budget. And we think, oh well, it's only a couple of transformers, we'll catch them up, that's fine. And then as operations, you're firefighting, we're spinning so many plates, and everyone is lean manned. It's the nature of the beast now. We're not tripping over people. We're typically at a deficit from a personnel perspective. So you're trying to do as much as you can with as little resources you have. So, and that's just the way of the world, unfortunately. So we've got these preventative plans in place, and I'm sure we all have. But then as they start adding up, essentially what we are doing by default is we're dropping them into that corrective bracket because we are running them to fail. I'm not saying if you've got a 5-year maintenance program, on the 5-year in one day, it's now, a ticking time bomb. But essentially you don't know, the longer that goes on, you don't know the operational condition of that. And as they start adding up, we all still feel that we're in that preventative maintenance bracket because we've got PM systems, we've got our CMMS in the background telling us what's due, and we've got a decent percentage of completion. But all those ones that aren't complete and the ones that we can't get to, we're dropped in that corrective bracket. So by default, we are on that run to fail approach on those things. And I've been in that position, and I know it's difficult then to try and push the needle the other way. So it's just something to reflect on. It's not a finger pointing exercise, but it is difficult to always be where you need to be and up to date. And obviously following on the cycle of safety from within NFPA 70 by by following that process, install it in the right way with the right codes, the right standards, following 70E to make sure you've got that protection of people and you maintain it in line with 70B. In reality, we should be reducing the the likelihood of having an incident. So I'll open that up, and again, we're not probing into it too much, but what do you base your maintenance program on? Are you corrective? Are you preventative, which is probably the majority, or are you maintenance legend? And have you got condition-based monitoring approach with sensors and single panes of glass looking at everything on all your networks?
It's just running now. I'll give it another couple of seconds for people to get their answers in. Let's get another 5, 4, 3.
There'll be 0 corrective. There's got to be
2, 1. Here are the results.
Yeah, 4%. Nice. Yeah, that's where the bulk of us sit. And when you're, especially when you're a manager or a leader, the higher you get and the further you get away from the pointy end, often you just see the greens on your PM schedules. What you don't see is I suppose, some of the caveats in the bottom, some of the things that didn't get done, some of the things that are still outstanding, some things that are carried forward. And it is hard to keep a tight ship. So hats off to anyone that's got 100% PM completion and you're in that middle bracket. Well done. Let's see how many clicks this takes this time. It stuck last time, didn't it, Ben? On the poll.
All working?
No. Should try a different platform to Zoom, should we? There's no rationale to it. Sometimes it's like 10 seconds and another time it's, oh, here we go. Right, so today, sorry about that. We've got we're going to use a fictional network that we've created, which is going to be our example to go through and then talk through our maintenance program based upon the asset list that we created first time around. So the network we've got an external grid transformer compound where we've got 2 oil-filled transformers. Oh, that's wrong. So the actual they are oil natural air force, so they're fan cooled with enclosed with exposed conductor in that compound. We've got an internal number 1 HV substation where we've got 10 11 kV oil circuit breakers and 1 vacuum circuit breaker. We've got an internal number 1 HV transformer substation where we've got 7 oil-filled transformers, a mix of synthetic and mineral oil. We've got an external auxiliary transformer switch station where we've got an external switch disconnector. And then we've got an auxiliary transformer substation where we've got 1 air natural cast resin transformer, an LV switchboard with a 1600 amp ACB. We've got a 3.3 kV ops switch room, which has got 5 SF6 circuit breakers and then 15 vacuum contactors feeding the operational equipment. And then we've got 2 LV switch rooms. We're just going to focus on the 3 1600 amp ACBs on those. So just a visual representation of that network. We've got the 2 grid transformers, which are 66 to 11 kV. They're both 12 MVA and they are oil natural air force. So they've got forced fan cooling on those. In an external compound with exposed conductor. So that's bare copper there, or aluminium. We've got an internal number 1 HV substation. So we've got an internal substation where we've got oil circuit breakers and vacuum circuit breakers. There's our 3.3 kV switchboard with our 5 SF6 circuit breakers, and then our vacuum contactors, 2 LV switchboards, a cast resin transformer. There's our outdoor switch, and there's our internal substation with our transformers in there. So I've mentioned a few different standards of what you might base your maintenance on. So there's a few out there. So in the FM world, a lot of people use SFG 20. There's some British standards that you might apply. There's IEC standards that are then so like 61936, which is referenced in a lot of countries worldwide in Europe. And then we've got NFPA 70B for the US, which we're going to be referencing today. And then obviously we've got O&M manuals. So lots of different references there around when you should be doing maintenance, what you should be doing maintenance wise. So we're going to focus on NFPA 70B because it's quite prescriptive, which is good, gives some good direction. And we're just going to use that as an example and then try and look between the gaps of the prescribed maintenance frequencies. So again, like if you're not familiar, there's some tables in there. It gives you details on the maintenance within there as well, but the tables as a reference. So you've got the product, so panel boards, power cables, and then it's got some key tasks in there like cleaning, inspection, mechanical, electrical testing. You'll notice on all equipment, it's got infrared thermography every 12 months. And then what we also see is you've got equipment condition assessment with 3 different types, condition 1, 2, and 3. We talked about in the last session around when you do you build your asset list, and you can put that wherever. It can be in your CMMS system, it can be in an asset management system, it could just be in a spreadsheet as long as it's usable for you. But as part of that, what we spoke about was doing your condition assessment. So the age of equipment, what it looks like, the environment it's in, the conditions it's under, so the load, what what the requirements are of it, so what the duty cycles are of that equipment. Lots of different things to take into account. Lots of different things that we'd cover which impact the overall condition of the asset. So just to clarify those points for those that aren't familiar, within NFPA 70B, there's these 3 different conditions. So condition 1, which you'll see has got the longest frequency. So for example, 60 months or 5 years for your longest duration, which it's where the equipment appears like new condition. The enclosure integrity is clean and moisture free. There's no notification from continuous monitoring, so any online monitoring systems you might have. And there's no active recommendations from any predictive techniques. And the previous maintenance that was done was conducted in line with the electrical maintenance plan. So essentially, it's been maintained when it should. You've got no flags or alarms. It looks good. It looks like new, and all's well in the world. So in fairness, we can come back to that within 60 months. That's fine. That's what from a prescriptive approach that would be looking at. The second condition is where the maintenance results deviate from past results, or they require more frequent in accordance with manufacturer. So this is an example where last time we spoke about possibly manufacturers' recalls, or where you might have an update on an operational restriction if they've changed the frequency, where it might have been originally a 5-year evolution, but because of any issues that they might have experienced, they might then put a safety bulletin or an update bulletin out to say you need to reduce your frequency to 36 months as an example. Or the previous maintenance cycles revealed issues that need action. So you might have identified something on your previous maintenance. It wasn't a showstopper, but it needs resolution and it could lead to something else. So you'd plan that in your 3-yearly cycle. And then again, any notifications from continuous monitoring or active recommendations from your predictive technique. So you would reduce your frequency down in line with that condition side of things. And finally, the lowest one, which is 12 monthly, typically is where your equipment's missed the last 2 maintenance cycles, or the previous 2 maintenance cycles revealed issues that require action. So you've got an outstanding action in there. You've got active notifications from continuous monitoring and urgent actions from predictive techniques. So in theory, your kit might have been brand new day 1. So you've gone, I've done my initial condition assessment, and this is a 60 months approach that I'm taking. It's condition 1, but for whatever reason, operations, life gets in the way. You can't get the shutdown, so then it drops into condition 2. You try and do your 12 monthlies. So potentially this equipment might not have been actually maintained for over 8 years by the point you actually get into condition 3. So it becomes this 12-monthly item to then jog, push it up the urgency to try and get you to shut it down to then do your maintenance. But obviously you don't know that operational condition of the equipment because actually it's on, but you don't know what operational state that equipment's in. So just for information, really, it's difficult to try and put something in around this, but if people can put in the chat maybe what you base your planned maintenance programs on. So in your locations, if you base it on SFG 20 in the FM environment, or if it's based on a British standard or an IEC standard or NFPA 70B, it would just be good just for a bit of information if you could pop in the chat what you base your maintenance on, and or if it's the O&M, if you use the O&M, the manufacturer's instructions every time, or it might be a local instruction. Like some companies have their own maintenance guidelines that they put in and interpret. So yeah, it would just be good to know, just for some feedback, to something to look into. So based upon those bits that we've got on, that we've talked about from 70B, which we're focusing on our theoretical network that we've got. Essentially, we've done our condition assessment at the start. Eddie's just come into his role. He's built his asset list, done his condition assessment, and in theory, we'll cover these a bit more in depth as we go. But in theory, the annual stuff that they're going to do is we're going to be doing inspections on an annual basis. We'll talk through frequencies and what's recommended and best practice. But essentially, we're going to be doing inspections of our switch rooms, our substations, our switchgear, our transformers, so everything within there, batteries. We've seen in there that it recommends a 12-monthly thermal survey, so thermography. Transformer oil samples. So again, next session, we're going to go right in depth with these ones. So we'll not go too far with that. But again, the transformer oil samples are so important because it gives you, it's a health, it tells you the transformer health. You know where you are with that asset and you can identify things early. Likewise with partial discharge testing. So that you can have an underlying, a small fault starting to develop that you can pick up with partial discharge testing. And if by doing that, just having that as part of your maintenance program, as part of your inspection regime, you can hopefully identify things early, which obviously hopefully don't result in an unplanned downtime or an arc flash if you're unlucky enough. I've put in there a little caveat, which we can bring up in a bit, might bring in a bit of debate, but I've got in there ANAN, so air natural, so cast resin or dry type transformer maintenance as an annual. Which we'll look at in a bit. So essentially, we would do that every year. We'd be looking at all our stuff that I've looked at on my network. I've put in there as 60 months. So I do that every year. And obviously, if any little changes come up, I then start looking and trying to adjust that as I go. Essentially, I would be doing that until the year 5 point. Any defects or things that were need to be replaced or any parts need to be done, I could order in time for my 5-yearly maintenance. And then the 5-yearly maintenance, which we'll cover a bit more in depth, we're going to be doing, shutting it down. It's going to be intrusive. So we're going to be doing all the mechanical maintenance, the electrical testing, protection testing. If we're doing any, if we've had any protection studies done, so fault level assessments, grading studies, or arc flash surveys, and we need to implement any changes into the relays, again, this is the time to do it. Because we've got the network off, we can change the settings in the relays, and then we can do the trip time testing of the breakers to those settings to make sure that it actually works. So it's good to try and correlate your activities around your maintenance program to get best use of your outages and your downtime. If there's any changes that you need to make or parts replacement, you can do it then. Obviously, your transformer maintenance. And what I've added in there is I would still include the annuals. So I know a lot of people that do the annuals and then they do that up until year 4 and then they just plan their maintenance in. So I would always do my annuals just to, for 2 reasons. For one, if you can identify any defects, you can bring them into your shutdown, your 5-year shutdown. So you might identify issues with your oil for your transformers, which might need further investigation. You might pick up some low-level partial discharge or a thermal difference on some connections. Then you can focus in on that on the shutdown and then do that. But another good thing is it gives you a baseline partial discharge reading and thermal readings close to the event. So what I would typically do is afterwards, this is really intrusive. You're disconnecting things, you're reconnecting things, and obviously you're putting it all back, and the integrity should be good. But there are occasions where you have altered, you have adjusted systems. So it's good to have a baseline to then when you follow it up and do another PD survey or a thermal survey, it's good to compare those baseline results to what the results are now to make sure you haven't had any significant change. So we're just going to go into the annual items, which should be non-invasive, so it shouldn't require any downtime. Again, a bit of a caveat in there. But what we're going to be talking through is, so we're going to be doing inspections of our substations, our transformer compounds, our switch compounds, the switch rooms, any of our electrical rooms and the equipment within there. It says 12 monthlies obviously recommended. I think that's a little bit, it's down to the, it's horses for courses. It's down to the network. It's down to your site arrangements. But from my experience, 12 months would be too long. 6 months is probably tolerable. Quarterly, ideal. I always try to do monthly purely because I know things change week by week. So they definitely change month by month. So they're going to change year by year. Things like the temperature changes, humidity level changes, dust and debris as your seasons change and things like that, load changes. There's so many things that can impact your network. It's good to keep close to the ground, but I appreciate obviously there's constraints in there, possibly geographical locations, possibly amount of resource, the size of your networks and things like that. So it's got to be reflective of what you've got, the risk that's there, and obviously the criticality of the equipment. But I would say, as a minimum 12-month, 6-month ideal, but the more inspections you do, the bigger picture you've got for everything on your network. So we're going to just cover things like, so signage, so at the location, the name of the location, is it legible? Is the sign still good? Any safety signage, so any voltages, danger notices, if there's any SOPs posted at the door, make sure they're there. If there's any restrictions around access, we should be notifying signs that there's no unauthorized personnel to go in there. We should be looking at things like security. So is the door locked? Are all padlocks in place? Have we got the right key issues and things like that? So make sure there's no break-ins. We have a lot of remote substations. So it's good to make sure that we haven't had anybody trying to break in and take any of the copper work or the metal work away. The integrity. So the integrity of the room. Is there any vents or louvers? Are they blown out? Is there any signs of damage from within or damage from outside going in? Which moves into fire suppression. So a lot of substations have fire suppression on. Some of them are like Inogen type systems, but a lot of the older ones, especially if you've got oil gear inside, might be CO2, which is an asphyxiant. So it's good to understand what fire protection systems you have. Are they maintained? Is there a procedure for accessing them? Often, if I do an audit, this is one of the things that I'll ask upon. And I've seen so many times where operators will leave the panel enabled and they'll just go inside. When you ask them, what's your logic behind this process, they'll say, well, it gives you an alarm of 30 seconds if there's a fire detected, so you've got loads of time to get out. But I wouldn't be racing against 20 something bottles of CO2 being discharged into the space, which removes the oxygen from there. You could fall over, you could trip, you could be disorientated. So things like that. And I've seen mechanical systems included where you've got a valve. Some people will close the valve but leave the panel enabled because they've got a mechanical isolation there. In that event of it operating, it would discharge the bottles up to the valve, and then it would pressure relief via a pressure relief valve into atmosphere. So you'd lose any of your fire suppression. So it's so important, especially from a loss prevention and risk management perspective, that you've got, if you have got that in place, that people understand how to use it. The infrastructure, and again, this is massively overlooked, but things like the roof condition, the integrity of the walls, the fire stopping. So if you've got a fire in that location, you don't want it to go into somewhere else. Down pipes linked in with the roof and the ceiling. If you've got any water systems above or it's external, any signs of leaks, anything that's going to give rise to danger, like water ingress into a substation, is all bad news. I'm sure we'll all agree. But the infrastructure is a key one. So then we're going to start looking at the system itself. So we're going to be looking at things like the switchgear, the transformers. We're going to be looking for any flags or alarms on the relays or any other protection systems we might have. Gauges. So if we've got any gauges for like oil levels or SF6 levels to make sure they're in the right location. One of the things I mentioned before and why it's important, there's a picture there on the right. It's an oil-filled transformer. Obviously, you can see that's leaking, so that would be something where I'd be identifying that, tracking it if it's not too bad, and then planning that in for my 5-yearly shutdown. As long as it doesn't get too bad, I would make sure I've got the parts, and I'll plan that in as what part of my intrusive maintenance. But the oil level on there, this is why I'm saying if you're doing a 12-monthly, you could go in the summer when you've got your oil's going to expand because of temperature, and your oil level might be fine. But in the winter, you might have a severe temperature swing, and your oil is going to contract and that oil level is going to drop. Sometimes it can drop massively and it'll go below the cyclast. And if you don't know what level your oil level is at, you don't know if it's below the bushings, which could lead to a flashover. So again, it's good to make sure you've got those periodic inspections planned in. That's why it's important, and you'll notice these subtle differences, which might be just linked to environmental conditions. So yeah, any leaks, you might have leaks from like compound fill boxes, oil circuit breakers, things like that. Housekeeping is really important. So there's a couple of pictures of there of storage of combustibles, which again, you don't want anything in there that's going to, from a loss prevention risk management perspective, where you can have a fire danger. A lot of this network's going to be critical to your network. It's difficult for people to firefight, especially with high consequence systems like electrical systems. And if you've got things like oil fill transformers, you've got potential fuel sources in there, which obviously are sustainable as long as your fire triangles present. Also, from storage perspective, people might keep things in there like spares, not relevant to the equipment, so it might be relevant to the process. They might keep documentation and drawings that's not relevant to anything in that room, might be relevant to the process. What the point is you only want people going into the rooms to interact with the equipment that's in there. So you only want to be going in there for your visual inspections, or if you're switching the equipment or maintaining the equipment. The more time you're in there, the increased probability is of you being in there when something goes wrong. So in reality, the less interactions you have in there, the less likelihood is of you being around when something goes wrong. So we're trying to only have the right people in there with the right authorizations, with the right competence when they need to go in. Housekeeping also tied into things like slips, trips, and falls. So things like you might have cables in there, you might have some insulated matting to make sure that's in good condition. Things like floor plates on cable ducts and things like that, make sure they're put back properly. Sometimes they get left and they can be a bit of a trip risk. You get a lot of those reported in. Documentation, so make sure things like your one-line diagrams or your single-line diagrams are current, your mimics are there and up to date. Any substation logbooks you might have. Emergency equipment, so things like your rescue hooks there, your signage, any first aid equipment such as like eye wash bottles and things like that, fire extinguishers, anything that's there provided for emergency circumstances. Locks and keys, so things like keys for your panels, your operational locks, keys for your battery, your battery tripping units. Without those, you're not going to get access. You're not going to be able to do an inspection. And you'd be surprised the amount of those that go missing and you can't get access to those. Lighting, so make sure you've got suitable lighting in there, and that's something that you should be often. These are seldom accessed, and a lot of light fittings go one at a time. You don't really flag it up until there's only one left. So again, it's good to keep on top of that because it's a key contributor to people slipping over or pressing the wrong thing, and an unplanned operation, a switchgear, things like that. So it's good to keep on top of that. Access and egress. Again, always knowing your escape routes, making sure you've got good clearances in front and behind the gear, especially when you've got withdrawn circuit breakers. The environmental conditions I've kind of mentioned, which brings me to my final point. My most important point is probably your battery tripping units. So the amount of times I go to site and they'll either be turned off. I've had them where they've been, I'll knock the supply off just to do a check and there'll be no voltage in the batteries. They're just massively overlooked in a lot of places in terms of maintenance. And it's the most important bit of equipment in that substation. Without those tripping batteries, none of your protection is going to work. So you've got no protection on your board at all. And it's something that's just massively overlooked. So if there's one thing to take away, just go back and ask your maintenance guys what they do on the batteries. And if there's any defects, how they highlight them. Because sometimes people know about it, but it hasn't actually filtered through to the people that can make a change. So if there's anything to take away, make sure your batteries are functional. Non-invasive testing continued. We're going to cover this more in depth than other ones because we're going to have some SMEs actually talking through what it is, how it comes about, how to detect it, how to interpret it. So I'll just touch on it now, but partial discharge is a massive tool in our wheelhouse, what we can use to identify low-lying faults before they actually escalate into an overarching failure. If there's a gap in a joint or a void or a bad connection, we'll start picking that up in low levels of corona discharge really early on if we're doing our regular inspections. Whereas as it starts getting bigger and bigger, we're leading to more towards an actual failure. We've got thermography, which is obviously recommended in NFPA 70B, where we can pick up temperature differential, we can pick up hotspots, things like that. And finally, transformer oil samples. So making sure you're doing your oil samples, but making sure you're interpreting the results and you're doing them to a standard that you're actually only going to get some benefit from. I had a client recently where they were doing samples based on their own internal standards. So when I benchmarked them, there were some issues around. They had things like they weren't doing DGA, so we're starting to indicate some dissolved gases in there. And additionally, they were doing acidity and water content, and actually they had a massive drop in dielectric strength. So what that meant was the actual insulating properties of the oil was starting to reduce quite a lot, which needed to be monitored and obviously acted upon at a certain point, because once it stops being an insulating medium, it'll just conduct, and that's where you're going to get a flash over the transformer. So these are things that they weren't testing for. So you've got to make sure you're testing for the right the right assets that you've got for the right voltage and to the right standards. And then finally, possibly a point of contention, but a lot of people lean towards dry type transformers, so cast resin transformers on the networks, because they're normally less expensive than oil filled. There's obviously, from a loss prevention and risk management perspective, insurance prefer that because you haven't got a fire risk with oil. Even if you use synthetic, it's still got a flash point at a certain point. There's less working parts. The maintenance there's supposed to be maintenance free, a lot of these. But typically, if you're going to follow the power transformer element within NFPA 70B, this would kind of fall in line with a 5-yearly item. What I will say is a lot of cast resin transformers, if you look into the manuals, it'll say 12 monthly. It needs to be like vacuum up any debris, wipe it down, clean it, check tightness of connections, which in theory is a fairly quick task. But obviously, because of the exposed conductor, you're not going to be doing that with a live. So you need to isolate it and earth it or ground it so that I can actually get access to the contacts in order to do that. So, and again, this might be a bit of contention, but something to take away is just to have a look at that. Because obviously it's difficult to get a shutdown every 5 years. So trying to get a shutdown every 12 months to do this maintenance might not fit with your maintenance strategy or your business's projected downtime. So I would just say, definitely refer back to your O&M manuals on that one.
And that's where it comes in and does it down. So we looked at a lot of like NFPA 70B, if it's in condition 1, it would tell you 60 months. But obviously, if your O&M instructions are saying every 12 months, then you need to be following your O&M instructions. Otherwise, things like warranties and things like that are straight out the window. So you might come into it, in 60 months' time to do your inspections, and then all of a sudden you realise, actual fact, there's a problem with it. But you know what? You're way past your warranty dates for the manufacturer's instructions. So understanding what takes precedence is really, really key. And obviously, I'm constantly running short of time on this webinar. Also, linking back to condition 1, we mentioned it before in the NFPA 70B standards, is condition 1 is 60 months, so 5 years. But no, the equipment might have never been used much at all, and it might be 5 years old. Actual fact, because it's never been used, if it's not had any mechanical checks in that period of time, you may then come to use it, classing it as normal operating condition. In actual fact, you might be waiting for an absolute massive catastrophic failure because the mechanics haven't ever been used in that period of time. So ultimately speaking, making sure that you're picking the right maintenance schedules for the equipment is really, really key. But yeah, I'm just conscious of time as well, so we'll pass on.
Yeah, I've talked too much. And then we kind of go into we'll just touch on it because we'll cover it in some other sessions, but the invasive maintenance of this one, we're going to be shutting it down. We're going to be doing, the switch gear maintenance, mechanical, so any clearances on our oil circuit breakers, you can test the oil or replace it, which is probably a better approach to take. Testing your vacuum bottles on vacuum circuit breakers, checking the integrity of your SF6 breakers, things like that. Your transformer maintenance, if you've got any investigations to do, obviously you've got potential where you can drop the oil or investigate further. Your protection systems, as I mentioned, make any changes. You can plan in any retrofit. As I mentioned before about thermography, it's a great tool, but only where you've got access to do things. So if you've got things like exposed conductor, overhead lines and things that where you can actually get to, or cast resin transformers where you've got access, or where you've got thermal imaging windows supplied. Obviously, it's not recommended then to remove covers live just to do thermography because you're giving rise to danger just to do a thermal survey. And then if you're not doing that, you're taking thermal survey of a cover, which you're not going to get anything from. So if that's the case, it might be an opportunity within your shutdown, possibly to retrofit or look at your design and include thermal windows as part of your design if you're putting new boards in, or retrofit things like that in your maintenance programs just to make your life and your maintenance team life a bit easier. And just finally, the battery tripping units. Again, can't emphasize, this is your opportunity. You've got your shutdown. Do your maintenance on your batteries. Replace your batteries if you need to, or maintain them, top them up. Whatever you need to do to make sure that they're functional, because it's the most important bit of kit in that substation. Any changes to your protection, get it done. Trip time test your breakers. So this is your opportunity to get all those prescriptive elements done physically. I'm just going to quickly cover some good finds. So these are like from experience, these are finds that we've captured. So this one is an external HV switch, which was it was fairly new, so it was given a 5-year category 1 process, and then some levels of PD were being indicated within 3 years. And on removal of cover, it turned out that the duct integrity had something's gone on there. So whether it's rodent ingress or something, but then also the vents as well had started to deteriorate, so they started letting dust and debris in. And on those bushings inside, you were getting a level of dust and debris on there, and there was fine levels of tracking on there. So it was starting to, you're getting PD and tracking on those bushings, and that was picked up obviously before it failed, which is ideal. Another external switch, which was again given a 5-year condition assessment. Within 3 years, they were getting PD readings on there, and that was the cable within the switch. So again, this is where that first example, that was reduced down to 3 years. So that was brought into 36 months purely because they needed to ensure that integrity was correct before they moved it back to 5-year. On this example, this was a thermography identification on a 13.8 kV transformer. You'll see there the nice shiny phase in the middle, and then this phase here where you start getting the burning and the discoloration. So that temperature differential was clear, and that allowed us to plan in a downtime, which was convenient with the business, investigate, and then repair and get it back online before any downtime, similarly in a CT chamber. So these are good examples of where you can pick things up using these predictive tools or things that are at your disposal as part of your inspections, and catch them before it leads into a catastrophic failure. These ones are too late. So there's a transformer that's failed on one of the bushings that flashed over, similarly on some cables. This is an air brake disconnector, which you wouldn't pick up like visually, but it was starting to get some arcing between contacts, which then resulted in it flashed over in the end. Same with an insulator there, which was corroding and then broke down and failed. And then these are all similar, where we've had compound fill boxes. There's been a void in there, and then it's got to a point where that PD, it's got to a point where it's tracked across, and you've had an earth to earth, a phase to earth fault, and we've had a circuit breaker failure, a transformer failure in a separate time, and this is a junction box failure. And this one here is an example of where oil samples they weren't getting done for DGA on transformers, so they were only doing water content and acidity, wasn't picking up dissolved gases, and this transformer failed catastrophic. That's a tap changer that failed, and if they had been, they would have probably identified metal to metal thermal contact inside that transformer where it's getting arcing. So that's why it's important to then do these condition-based approaches and these snapshots for the equipment health. So just to summarize, I'm just conscious of time. Hopefully it's give a bit of an idea around how to achieve a baseline standard condition from your maintenance perspective, but you might always slip back if you're not on top of it. So, and we're all human. So it's just trying to understand where you sit, then try and push the needle right and make sure you've got a reliable and a safe network. And hopefully that'll give you an improved reliability and achieve a common standard by following what your local, whether it's an IEC process or NFPA 70B or the O&M manual, and a combination of all of those, just whatever works for you and whatever fits your geographical requirements to make sure you've got compliance achieved with a positive intent. So as I mentioned, next time we're going to cover a deep dive into transformer oil samples, the results, how to interpret them, and how that leads into electrical safety. So with that, if you want to schedule a session to talk about any of this or how we can support you, let us know. And just a quick flag to say we have got a conference coming up in a few weeks in the US for electrical safety and operational reliability in Chantilly, Virginia. So if you're interested in attending, let us know, and we can get you some details. Thanks for attending, and if I've got time for any questions, Ben.
Yeah, we do. Yep. We'll have to fly through some. So the first one is for Joby. So how do we consider the aging and the life cycle of equipment?
That's a good question. So that when we cover the aging, I suppose, and when you're doing your asset verification, your age and I suppose your life cycle and what your expectation is of your asset is, they're the three things that you need to be considering alongside what the environment's like what the load's like on the asset. So as an example, you might have a aging bit of equipment that is in a good environment, it's maintained, it's still in good condition, and the load is tolerable. It's got a good load. You can verify that by either power quality studies or a similar process. And as long as you're maintaining that asset and you're monitoring its operational health, then there's no reason why you can't prolong the life of that asset. That's the whole point in the condition-based approach. The condition-based approach is to extend your maintenance out, and you're always monitoring those assets. But when you're taking snapshots, and it depends if you're doing your maintenance and things, it depends on the environment. If it's wet, if it's humid, if it's hot, if it's cold, if there's chemical environments, it's all down to your individual condition assessment of your asset.
Good stuff, thank you. So for the next one, this is from Prashant. So how thermal surveys of transformers help with assessing the condition? Is it worth doing?
If you've got access, so it depends on your type of transformer, I would say. So definitely, yeah, if the oil-filled transformers, then your annual oil samples are a, a massive snapshot at the health condition of that asset. So that's definitely the recommended process if you've got an oil-filled asset. If you've got exposed conductor on there, so depending where you're located, like a lot in Europe, you might have exposed conductors on your HV and LV sides of your transformer. So if you've got access and you've got you can respect your safety distances and you can get access for your thermal survey, definitely, because if you're going to start getting any loose connections, especially on cast resin transformers and things like that, then I would definitely do thermal surveys on those. The only downside is a lot of transformers have enclosed conductors, so they're within junction boxes. So it's that it's what it's going to add. You can't remove any covers, so it's pointless doing a survey of a metal cover. You're not going to get anything from it.
Thank you, Dan. So just bit of info from Richard Little. So Richard, big shout out thank you for putting a lot of bits of information in the chat throughout. So just in reference to thermography, it's only as good as the user or photo assessor. So recent issues that they never had any training, just point and shoot. Therefore, reports were not much worth on paper or printed. Currently working on a large UK OEM to get this all sorted out. So thank you for sharing that.
Yeah, thanks, Richard. I agree with that point.
So the next part is this is a different one from Prashant. Can we use CRC cleaning agent for transformer cleaning?
I think you'd have to go to the manufacturer. So if you a lot of the cast resin will give you recommended cleaning agents. And a point that I forgot to put in there was around grease as well for sorry, I should have mentioned it for the switchgear stuff. Just make sure a point to consider for your mechanical maintenance, for your lubrication and your greasing, just make sure you use the right grease both from the supplier, like the OEM perspective, but also to the environment. There's a lot of issues around using the wrong type of grease on contacts and mechanisms where it can dry out and either not open, which is terrible, or it can also not close as well, which is not ideal. So it'll dry out and then you'll mechanically be stuck in that position. So yeah, for your question, I would say go back to your O&M manual and just see what the recommended cleaning agent is. But definitely from a grease perspective, make sure you do a little bit of due diligence in that and select the right grease that if you're doing any maintenance.
Good stuff. And I think this is the last one here, Dan. So the condensation in switchgear, idle bus, which charge condition but no load. How do we check?
Interesting. So most switchgear you'll have anti-condensation heaters. Well, depends on the environment, but anywhere where you envisage condensation, so in humid conditions, you normally have anti-condensation heaters fitted within your switchgear. Often though the heater will be within, but the actual control side will be without, so it'll be inside like the control panel as an example. So typically you can tell if it's working or not. Visually, it's difficult. A lot of new switch gear. So this is an area where you often get PD from humid conditions, and obviously you can then start getting if you've got any dust or debris on your conductors. When you start getting moisture in there, that's where you start getting tracking between those bits of dust, and that's where it ultimately results in a flashover. So a lot of new equipment as a standard, it'll come with like humidity and temperature sensors, which are going to be covered in the condition monitoring side, but they're massively helpful in terms of reducing issues in moist environments. So yeah, that I would say that's the long-term option for trying to mitigate those.
Good stuff. And that was the last one, Dan. Thank you.
No, perfect. Well, thanks everyone for attending. Hopefully you got something from it. And I know it sounds riveting, but the next one should be a good one, a collaborative session to go through, interpret, and transform royal samples. So thanks very much.
Yep. So in the next few days, we'll have the recording sent out, shared via link. It'll be on our website in due course as well. We can share this presentation as and when people need it. So if you are interested, please let us know. Thank you for joining.
Thank you all.
Thank you.
Excellent session.
Thank you. Take care,
Thanks for
everyone.
all the chats and contributions as well. Brilliant. See you all again.
Thank you. I'm going to shut this down now anyway. Take care,
Yeah, cheers,
everyone.
Ben. Thank you.
Bye.
Cheers.
Bye.
See ya.